everybody. All right, let's actually compute the centroid of an example this time. So let's start with something simple like a triangle here. So we know the base and the height, and we want to compute the centroid. So we need to do these computations, which really breaks down to let's compute this denominator and then this numerator for the x component and this numerator for the y, right? We just need to get these three, then we can get everything. So let's just do one at a time. Let's say area. And we know the answer actually is 1/2 base times height, right? But just to go through the method of how to set up the integral. So differential area, right? This differential area is, there's dx and dy. So dA is dx times dy. So we can already decompose dA into dx dy. And then you integrate each way. And which you do first kind of just depends on if the shape, if it's a function or if it's not a function. So let's just go dy dx. So you integrate dy, then dx. So that's what this is. But then what about the limits of integration? Okay, in the y direction, we're going from here, this function, which in this particular example, that function happens to just be 0, right? Up to here, this function, y2. In this example, the slope is rise over run, the y-intercept is 0. Okay, so in the y direction, you're integrating from this function up to this function to this function, which gives you this like infinitesimally thin slice. And then you add up all the slices from here to here, right? It's from, in this example, from 0 to b. Okay, so then that's how you set it up. Now you just compute the integral, right? So integrate dy is y from 0 to h over bx. And then once you do that, then you work your way out. Right, so let's evaluate that. That's h over bx. Then dx like this. And let's integrate that. Half x squared from 0 to b. Right, so then it's half h b squared over b, right? 1/2 base times height, just like we expected. Okay, now let's try one of the other ones. How about this one? All right, so similarly, let's split up dA into dy dx. Same limits of integration, right? y1 was 0, y2 was h over bx. In the x direction from 0 to b. And then let's do it, the integral. So we're integrating y, so we don't care about x. So integrate dy becomes y. And then the rest of it, this, right? So let's evaluate y. That's h over bx times the other x. Okay, let's integrate this from 0 to b. So then that's h, well there's a 3, and then b cubed over b squared. Okay, so that means hb squared over 3 is the numerator. The denominator was half h times b. So then that becomes 2/3 b. So there you go. That's the location of the x component of the centroid. Now let's do the other one. So y dA. So same setup. dy dx. Let's integrate in the y direction from 0 to h over b x. In the x direction, 0 to b. Okay, let's integrate y dy. Half y squared from 0 to h over b x. And the rest of it. Okay, let's evaluate that. So let's see, that's half. So we have to square it. H squared, b squared, x squared. All right, so let's integrate this. So x3 over 3 from 0 to b. So that's b cubed over 3, so then that's this cancels that. Okay, so that's h squared b over 6. Okay, so the y component of the centroid is h squared b over 6 is the numerator. The denominator was this, so that means 1/3 b cancels h squared over h, 1/3 h. So there we go. So these are the coordinates, right? 2/3 base, 1/3 height. So kind of like here, right? 2/3 base, 1/3 height. Okay, give this a try. Let me know if you have questions. I'll see you on the next video.